some missing number problems that all involve multiplication and division. So can you please warm your brains up for our Monday morning by working out what the missing letters are in each of these calculations to make them correct. So we're kind of carrying on with our algebra from last week, where we've got our missing numbers using letters. So see if you can work out using your times tables facts these missing letters A, B, C, D and E. Well done. So Brody, try using the letter instead of saying 1 equals 8. I know what you mean when you say 1, you mean question 1, but that then looks like 1 is equal to 8, which is not. So try using A equals 8 instead. But you're absolutely right, it is 8. Well done. So what would B equal? So I know that 3 times 8 is 24. So A would be 8. What would B equal? Well done, Brody, that's better. Well done, Abina. So Alex, think what's 6 times 8? Is 6 times 8 72? Cool, so we know that 9 times 8 is 72, and if you think about your algebra from last week, I can work backwards. So I can think instead of doing something times 8 is 72, I can do 72, and if I'm working backwards, I use the inverse, so it would be divided by 8, so B would be 9. 36 divided by C equals 4. If I remember my number facts, the 36 goes at the top, divided by C is going to equal 4. So another way of doing that could be to do 36 divided by 4, which would be 9 as well. 30 divided by something equals 6, that D would be 5. Now then, E. I've got E times E, which means I'm doing a number times by itself to make 36. Well done, Brody, well done. Alex, excellent. E, it would have to be 6, wouldn't it? Because 6 times 6 equals 36. Another way I could write that is I could write E squared, because it's E times by itself equals 36. Lovely, brilliant, well done. So while we're on the subject of square numbers, can you please start off by working out for me what the answer to each of these would be? So I want to know what 1 squared is, 5 squared, 7 squared, 12 squared, and then 20 squared. Think about that one very carefully. Then as a challenge, which numbers in this list, in the green list, are square numbers? So which of these numbers have been made by multiplying a number by itself? Well done, Imogen, well corrected. David, have a think about that. Is 1 times 1 2? 1 add 1 is 2. Is 1 times 1 2? Well done. Cool, so 1 times 1 would be 1. 5 squared means 5 times 5, so that would be 25. 7 squared means 7 times 7, so that would be 49. Well done. 12 squared means 12 times 12, so that would be 144. 20 squared, so I want 20 times 20. So think about working through that one. Think about 2 times 2. And then think about how you'd make it 20 times 2. And then how you'd make it 20 times 20. So we know that 20 times 20 would equal 400. Well done. Cool. So which of these numbers in this rectangle here would be square numbers? Which of them are square numbers? And what is their square root? Their square root. So Luca thinks 16 and 81. Do we agree with Luca? Good, so 16 definitely is. So if we wanted the square root, so that symbol that I've just drawn there means square root of 16, it would be 4, because 4 squared is 16. Brilliant. Yeah, well done, Luca, and well done, Abina. So 81 is the other one, which the square root of 81 is 9. Okay, so 81 and 16 are square numbers, okay, because they are made by multiplying a number by itself. Brilliant. None of the others are square numbers because they're not made by multiplying anything by themselves. Excellent. Now, as well as square numbers, you can also have cube numbers. So I could have 2 cubed. Let me just write that down for you. What do you think happens when it's cubed? What does cubed mean, do you think? Well done, David. Cubed means it's times by itself 3 times. Doesn't mean it's times by 3, times by itself 3 times. So 2 times 2 would be 4, and then times it by 2 again would be 8. Okay, so it's not 2 times 3, because that would be 6. It's 2 times 2 times 2. Okay, so let's try 3 cubed. Okay, so that would mean 3 times 3 times 3. So what is 3 times 3? Well done, Imogen, yeah. So 3 times 3 is 9, and then times that by 3 again would make 27. Very good, okay? Does that make sense? So that means that 8 and 27 are cube numbers. So they're not square numbers, but they are cubed numbers because they can be cubed. Okay, and a way that we'd write cube root of 8 is we'd do it like square root, but we'd put a little 3 there. Okay, and the cube root of 8 is 2. The cube root of 27 would be 3, because 3 is the number that has been times by itself 3 times to make 27. Does that make sense? It's not often that you're going to have to come across the cube root, but it's just interesting to start exploring that number. Okay, right, so let's get back into our area and perimeter of rectangles and squares. Can anybody remind me what we do to find the area of rectangles? What do we have to do to find the area of rectangles? Times whatever. You've said times, which is correct. Good. Length times width. Yeah, brilliant. Oh, good, Phoebe. Okay, so our formula, which links in with our algebra from last week, is length times width equals the area of a rectangle. Length times width. Okay, so we're using these letters L and W to represent the numbers that we may or may not know. Okay, so the length of this shape here is 7 centimeters, and the width, the longest bit is the length and the wide bit is the width. So to work that out, we're going to do 7 times 4, and if you think about it as this being split into 4 sections this way, and this being split into 7 sections this way, that's why we're doing length times width. Okay, we're imagining it's been split. Okay, was that 7? 1, 2, 3, 4, 5, 6. Wow, that was great measuring. Well done, me. And then you're multiplying it to work out basically how many squares it would be altogether. So 7 times 4 is 28. Okay, but remember, 28 isn't the answer because I've also got to think that I'm doing centimeters multiplied by centimeters. I'm doing centimeters times by themselves, which is another way of saying that would be to put centimeters squared, wouldn't it? If I times something by itself, it's squared. So I would put centimeters squared. Okay, you can't write squared on your chat, so don't worry too much about that as long as you are confident that you would need to do it. So what about this shape here? Can you please work out what this shape here would have as its area? What would be the area of that rectangle there? So it's in inches this time, so I'm doing inches times inches. Well done, brilliant. Well done, excellent. So I'd have to do 2 inches times by 15 inches, which would end up being 30 inches squared. Okay, brilliant. Now this one, I've only been given one measurement. Why do you think that might be? Looking at this shape, why do you think I've only been given one of the sides? Good, well done, Abina. It's a square. So if it's a square, then all the sides are the same length. So I know that then the length and the width will both be 10 meters. So what would my area be? Not 10 times 4. That would work out the perimeter because you've then done 10 add 10 add 10 add 10. Remember, to find the area, you've got to do the length times the width. So the width is 10 and the length is 10. It wouldn't be 40, no, so we're not timesing it by 4. If I was timesing it by 4, that would mean that this side was 4 meters, and then that wouldn't be a square. That would be a rectangle. Okay, so I've got to do 10 times 10. No, not 20. I'm not adding them. Remember, you're doing length times width. So the length is 10 times by the width, which is also 10. So I'm doing 10 times 10. So what would 10 times 10 be? Good, 100. So it'll be 100, and then I'm doing meters times by meters, so it'll be meters squared, 100 meters squared. Okay, can we see why it's not 400 or 40? Can everybody see why those were wrong? Okay, we've got 10 meters on this side, we've got 10 meters on this side, so just like we did 4 times 7 here, and just like we did 2 times 15 here, we're going to do 10 times 10 for the square. Okay, so let's have a look at some then where we've got missing numbers. So here on the inside of each shape, I've given you the area of the shape, and then I've given you one of the lengths, and I want you to work out what the missing sides would be. Okay, we'll give this one C. Okay, so what would A have to be to make it 12 meters squared? What would B have to be to make it 8 meters squared? And what would C have to be to make the area of that square 16 meters squared? Well corrected, Martin. Well done, David. Yeah. So tell me what A is, David. Well done, Luca. Alex, which one of you said is 8? Yeah, good, well done. Okay, so let's have a look at how I'd go about working this out. I know that to work out the area of a rectangle or a square, I have to do length times width. Okay, in this shape here, my length is 4, and I'm timesing it by A, which at the moment I don't know, and my answer has got to be 12. Okay, so now this is just using my multiplication skills. I know that 4 times A is 12, so to work out A, I could do 12 divided by 4, so therefore A must be 3 meters. Okay, to work out the area of B, I know that it'll be length times width. So my length, the longest bit, is B, and I'm timesing it by the width, which is going to be 1, and it's got to make 8. Okay, so what number times by 1 makes 8? The answer would be 8. So B would have to be 8 meters. Okay, now C is a bit more difficult because I haven't got any measurements. However, I do know that it's a square. And I also know that 16 is a square number. So what is the square root of 16? What number do I times by itself? Because it'll have to be C times by C to make 16. So what number do I times by itself to make 16? 4. So then C would be 4 on both of these sides, 4 meters. Okay, does that make sense to everybody? Hopefully that was just a quick recap, okay, because we're going to move on now to something a little bit different, we're going to look at the area of some parallelograms. Now, parallelograms are really easy to find the area of because, let me show you something magical, hopefully. If you look at a parallelogram, it's a squashed rectangle, isn't it? It's been knocked over at the top. Now, if I drew a line down here, and imagine I took my scissors and I chopped this right angle triangle off now, okay, and I picked it up and I attached it here instead, what shape, if I chopped that bit off and attached it here, what shape would I have made? Well done, Abina, a rectangle. Okay, so even though a parallelogram looks a really funny shape to find the area of, actually the area inside that shape is exactly the same as the area of a rectangle. So we can do the exact same thing as we would with a rectangle. We find the length of the base, the length of the bottom of my parallelogram, and we find the height, the width of my parallelogram, and we times the two together. Okay, so for this parallelogram, we would do 12 times 5, which would be 60 centimeters squared. Okay, so using that example, can you work out what would be the area of this parallelogram? Let's call this one B, and this parallelogram, let's call this one C. Can you work out, please, what would be the area of B and C? Any thoughts? What would be the area of B? So remember, it's just like finding the area of a rectangle, okay? Because it's basically just a rectangle that's gotten squashed. Bro. Okay, so to work out B, I'm going to do the base, which is 3, times by the height, which is 10. So B area would be 10 meters squared. Okay. Martin, what aren't you sure of? What don't you understand? What are you confused about? So remember, it's just a squashed rectangle. Yep, that's fine, Imogen. You don't have to contribute in the chat. It just helps me to see that you're understanding it. Martin, what is it that's surprising that you're finding difficult? Well done, Alex. Well done, David. So for this next one, we're just going to do for C, we're going to do 6 times 5, and that is 30 feet squared. Well done. Good. So Martin, it's not so much that we're turning it into a rectangle. I'm just showing you that the area taken up by the parallelogram, if I chopped this little triangle off the end here and picked it up and put it over here, it would make that shape a perfect rectangle. So I'm just proving to you that you can find the area of a parallelogram by doing the exact same thing as you would if it was a rectangle. So like here, if I draw a line straight from this corner straight down and chopped this triangle bit off here and moved it over to here, then it would make this shape here a perfect rectangle. Okay, and we know that to find the area of rectangles, we do length times width or base times height. Okay, so I'm using the base, this bit here, and I'm timesing it by the height, this bit here. Okay, so for this one, I've done the base 5 feet times by the height 6 feet. Okay, so I've done 6 times 5 is 30. So it's quite a nice, easy shape to do. Okay, Now I'm just going to really quickly show you, and you're not going to need to do this bit today, but I'm going to show you anyway, how we find the area of triangles. Now, what you'll find here is I've got a right angle triangle, okay? But for the sake of this, just to show you how we find the area of triangles, I'm going to put this right angle triangle inside a square. Okay, now you'll see that that square fits perfectly over. It's got the same size length and the same size height, or the same size base, the bottom, and the same size height, the same height, okay? So if I was working out the area of that square, what would it be? Hang on, actually, I'm just going to make the number a little bit easier to use. Let's make that 4 by 4. Okay, if I was going to work out the area of that square, how would I work out the area? Good, 4 times 4 would be 16, wouldn't it? Gabriella, yeah, if it was a 7 times 7, you're right, it would be 49. I've just changed it to 4 times 4 because it'll make it easier for when we come to do the square. So this whole shaded section here is going to be worth 16 centimeters squared, okay? Now, do you notice anything about how much of that area is taken up by the triangle inside it? How much of that space is taken up by this right angle triangle? Good, exactly, it's half. So if the area of the whole square was 16, what would the area of just the triangle be? So the area of just the triangle would be 8 centimeters squared. Good. Okay, so I'm going to move this square now. Okay, the square was worth 16 centimeters squared, and the triangle is only half of that. Okay, so we've halved it. So in this one here, this rectangle here, okay, the rectangle, the area would be 3 times 12. So let's move this rectangle here. So it would be 3 times 12 for the rectangle, which would be 36 centimeters squared, and this triangle was exactly half of the rectangle. So what would the area of the triangle be? What's half of 36? If we need to do a bus stop, we can. Divided by 2. 2's into 3 goes 1, with 1 remaining. 2's into 16 goes 8. So this triangle would have an area of 18 centimeters squared. Okay. Now then, this is really, really helpful. Any triangle you ever find, the way you work out the area is you do the base times the height, which is what we've done to work out the area of the rectangle, and then you divide it by 2, you half it. Okay, now sometimes you'll be given a triangle like this, and it won't have a rectangle around it. Okay, it'll just have the numbers here. Let's do 7 and 4. And it'll say to you, find the area of this triangle. Okay, and what you've got to do is imagine a imaginary rectangle around it. And you're going to do the base, 7, times by the height, 4. And then you're going to divide it by 2. Okay, so 7 times 4 is 28. So that would give me the area of the whole rectangle. And then divide it by 2, which tells you 14. So the area of the triangle would be 14 meters squared. Now, you can draw this rectangle to help you, but actually you don't need to. The fact that there's a rectangle there isn't important. It's only important in that you understand why you're doing the length times the width, or the base times the height, and then halving it, because the halving it bit is the bit that you need to remember to do. Does that make sense to everybody? You're not going to do that today. I'm going to give you that to do as an activity tomorrow. Okay, so what you're going to do in math today is you're going to have a go at finding the area of rectangles and parallelograms. Now remember, parallelograms are just knocked over rectangles, so you find the area of a parallelogram in the exact same way. You do length times width, or base times height. Okay, then what you can do is a bit of a challenge. If you want to do a snow challenge, is you could go and have a go at seeing how many different rectangles you can make that have got an area of 48 feet squared. And when I say feet squared, I mean just use your feet. Okay, so one possible way you could do it would be, how do I make 48? Could be 4 times 12. So you could measure 4 footsteps and then 12 footsteps wide, or